As Ben said, I'm Zack Hayden, so I'm a faculty member in the horticulture department at MSU, where I'm the soil and nutrient management specialist for vegetable production in the state. So today we're going to talk about some of the basic principles for understanding use of organic fertility sources in vegetable systems, really any system. As Ben mentioned, as we've got more talk of regenerative agriculture, a lot of, simple questions come up about how we manage organic fertility, both in organic certified systems as well as what we call integrated systems. So, conventional systems where you're also utilizing organic sources. So, as a little bit of background, so you know who's talking to you. So, my research program focuses specifically on a couple of areas. So, we've worked quite a bit on nitrogen management in organic, conventional, and integrated systems across the state. So, we work across uh, scales and methods of production. So, from our largest vegetable growers in the state all the way to our market gardeners, and again, organic, conventional, and integrated. So, another part of my program is looking at, well, how do we build the longer term health and fertility of our soils? And in that area, I work on conservation strategies such as cover cropping and reduced tillage in particular, where we're looking to build soil health and crop resilience over time. And finally, I also, in my lab, work on technologies to help us make better decisions about nutrient management in season. So, in particular, looking at how we can use sensors, whether they're remote on drones or uh, proximal in the soil for targeting precision crop and nutrient management decisions. So that's kind of a background of what I do and the kinds of questions we could dig deeper into uh, as we go or after the talk here. All right. So before I talk or begin on any talks about soil and nutrient management, I really like frameworks or putting things into perspective. So if we're thinking about uh, in-season soil fertility management, it's not all just about the nutrients. We really need to put all this in context. So the first thing you really need to have figured out is light and temperature, and a lot of times that's out of your control. But absolutely, the next thing is water in terms of importance. A lot of nutrient management challenges with a crop are actually water issues. And then after that, we think about making sure we have a handle on what our pH is and managing that. And once we've got that, then you move on to your major macro and secondary macronutrients. So especially your NPK. And then once you got that figured out for your crop production, now we start thinking about micros. And at the very, very tip top of that pyramid are things like biologicals and the latest specialty fertilizers. So you really don't need to worry about those things until you've made sure that you've got all these other things figured out. Now, that's kind of the in-season nutrient management, but we also hear a lot more, and it's just as important, about managing our soils for the longer term. And a good way to summarize practices that we think about falling in this area are looking at the four soil health principles from the Natural Resources Conservation Service. So things like maximizing continuous living roots, minimizing disturbance, maximizing soil cover, and maximizing biodiversity. So easier said than done, but there's practices that we consider uh, that fall into these categories. Now, a lot of what those practices are getting at and the basis for building our soils over the long term uh, that is so important for organic production and regenerative production, a lot of it comes down to managing or building soil organic matter. So, as many of us are familiar with, soil organic matter plays many important roles for the health and fertility of our soils, from soil microbial activity diversity impacting soil structure, and of course, water holding capacity. For our purposes today, it's also a huge component or plays huge roles in nutrient cycling. So if we're going to build soils over time and build organic matter, there's really two basic ways to do it, right? So we increase organic matter inputs or we reduce organic matter losses. So reducing losses through erosion or decomposition, that's usually things like reduced tillage. On the other side, increasing organic matter inputs. Now, this is where we're trying to increase input of cover crop or crop residues, organic fertilizers, or manures or compost. So a lot of that is organic nutrient management, and that's kind of what we're going to dig into a little bit more today. The basic principles you need to understand to manage those well. Okay, so organic fertility management toolbox. What are we dealing with when we talk about organic fertility sources? And I'm going to be clear here. Uh, Most of the talk, if I say an organic source or organic fertility, I'm talking about amendments themselves, amendments that contain carbon and hydrogen. Uh, I'll try to point out if I'm talking specifically about USDA certified organic production, but hopefully this talk will be helpful in managing these organic fertility sources, regardless of whether you're certified organic or not. So the amendments we're interested in for organic fertility management. First, you have native soil organic matter. A lot of times we're trying to build that organic matter over time so it can provide nutrients in the future. But then we're also looking at things like cover crops, manures, compost, and a whole host of organic fertilizers, which I've kind of listed some here that range from plant products, animal byproducts, fish, some mineral sources that we'll talk about later, some of which are soluble, some of which aren't, um, and just a wide diversity and many combinations of these products as well. But when we look at these fertility sources, we end up with some key challenges. There's some key things we uh, that are different about organic fertility sources compared to our conventional or synthetic fertilizers. So a couple are listed here. Some I'll highlight are usually have low nutrient concentrations overall, especially of nitrogen. We've got incomplete availability of that nitrogen in the first season. These are Many of them are combined nutrients, nutrient fertilizers, and the nutrient ratios, as we'll talk about later, are often imbalanced. So um, if you try to apply enough of one nutrient, you might get too much of another. There are also some application challenges in terms of these fertilizers tend to be more bulky. They tend to be more expensive. There are some added regulations you have to worry about for some of these in terms of application timing. And then probably the biggest challenge or what's different is that getting your nutrients from these relies heavily on soil biology and decomposition processes and all the complexity that comes with that. So you're not just putting the fertilizer down and it's instantly available to the crop. There's a delay, and a lot of it is going to depend on the composition of those products or amendments, as well as the environmental conditions and soil conditions that it's taking place in. All right, so a little bit of level setting here. So we talked about what's different with organic fertility sources, but what stays the same? And a lot does. And I think this doesn't get pointed out enough. So first, the importance of soil testing and using it to inform nutrient management. That doesn't go away. Basic principles, crop nutrient demand, soil fertility, basic agronomy. Uh, that all stays consistent. Nutrient losses and environmental concerns. Just because we're using manures or compost doesn't mean that we don't have to worry about nutrient losses and the environmental issues that come with that. And also the concepts between 4R nutrient management. So we talk about uh, making sure we're thinking about the right source, the right rate, right time, and the right place uh, to optimize crop fertility and minimize nutrient losses to the environment. All of those concepts still hold true. We just have to adjust them for some of these the specific principles of these organic sources. Okay, so what are we going to do today? Uh, First, I want to talk briefly about soil testing as still the foundation here. And then we'll jump into a little bit of how we manage phosphorus and potassium with organic sources or how we think about those. Then we're going to spend the bulk of the presentation thinking about principles for organic and integrated nitrogen management, because that tends to be the most challenging nutrient to manage with organic sources. And then finally, we'll put it all into practice and hopefully have some time for questions to dig into more specific topics. All right, so all of nutrient management, good nutrient management starts with soil testing for lime and nutrient requirements. Everybody's heard this before. A couple things I want to point out though are, we think about avoiding yield loss or, checking our soil test to see what micros we need to add, but often the greatest value from a soil test is knowing what you don't need to add. So how much do we have in the bank of particular macronutrients? So when you get a soil test, the big three things you really need to pay attention to: pH, phosphorus, potassium. So phosphorus and potassium, these are those macronutrients that really don't move a whole lot in the soil. So when you get your soil test, you see a value, you can be relatively confident that that represents the bank you have available in your soil. Now, I'm not going to go into depth on soil testing, but if you need a refresher on how to take a good soil sample, this is a great resource, oldie but a goodie. And some of the tools of the trade, you have a soil probe, that's great. You can still get good soil samples even with a trowel if you follow the right methods. Uh, and one of the key things is making sure you're taking representative samples of the intended area from a consistent depth. And then how frequently should you take soil samples? Well, every 1 to 3 years, really based on your complexity and needs. If you've got a pretty simple rotation, maybe every 3 years is fine. If you're on a diversified system, a lot of different crops going on, soil sampling more frequently may be of value to you. Okay, so you got your soil test. You're going to submit it to a certified and respected lab, and you're going to get recommendations and soil test results. And they may come in a lot of different formats, depending what lab you're submitting to, whether you're working with a consultant, and you'll get a lot of potentially different nutrient and lime recommendations. So one of the things that often comes up is, well, how do I easily take these values from different soil testing labs and see what MSU recommendations are? And sure enough, thankfully, we've got a great tool to help with this. So I wanted to make sure to mention the MSU Fertilizer Recommendation Program. So this is an online tool, an interactive calculator where you can take soil test results from any lab, input them in, and get MSU lime and nutrient recommendations for the entire diversity of crops that we grow in Michigan. So it's a really useful tool. And then I also want to point out this resource, nutrient recommendations for vegetable crops in Michigan. Now, it is not organic fertility focused, but it has basically everything you need to know about managing nutrients for vegetable crops in general and how to think about it, all these general principles and what the nutrient requirements and recommendations are for the various vegetable crops. So just an incredibly useful resource that you should have um, in your back pocket. And I'll link to all these resources at the end of the presentation. All right, so this is what it looks like. So basically, online tool, you can put in your soil test results. I'm not going to go into too depth. Select your crop, select a yield goal, and then you're going to get a recommendation report that looks very much like what you would have gotten from the MSU soil testing lab. And, many of you are probably familiar with soil test reports. So you've got your results here, soil pH, and then we're going to have our macronutrients, especially phosphorus and potassium, whether you're in that below to above optimum range. And then you're going to get your MSU recommendations specific to that crop. So in this case, we'll see that we had pretty high phosphorus. That's pretty common. And our phosphorus recommendation is actually 0 for this specific soil test. All right. So let's talk a little bit about phosphorus and potassium specifically from organic sources first. So again, I'm starting out with those two because once you get your soil test, your recommendations for phosphorus and potassium for any crop are going to take into account how much you have in the bank. So we're going to start there and make sure we've covered any recommendations. Now, I threw up a couple common organic sources of fertility. So manure, compost, combination fertilizers derived from things like feather meal, and let's say a fish product that's a 511. So a couple key points I want to make when you're thinking about managing phosphorus and potassium recs. So the majority of your organic nutrient sources are going to contain a suite of these nutrients, as we know. Now, if you want to take credit, so how much of the phosphorus and potassium you can expect to become plant available in the first season from some of these sources, these organic sources. So you can assume about 80% of the phosphorus in there will be plant available in the first season, so it could be used to meet any recommendations. And then with potassium, potassium doesn't really integrate into organic compounds. So the potassium in those materials, generally, when you put that down, you can assume about 100% of that potassium as potash, K2O, will become available or be available to your crop. So another thing to note, you'll often get from your soil test micronutrient recommendations for specific crops. If you're applying manures or composts at typical application rates, a lot of times, I mean, you can look at the label, but a lot of times those sources will also contain sufficient micronutrients for growth of a lot of vegetables. So these are some common organic sources. So organic in the sense of they contain carbon and hydrogen bonds, so organic compounds. There are also a few, if you are a certified organic grower, a number of OMRI approved mineral sources. So non-synthetic mineral sources of phosphorus and potassium in particular, usually combined with other things. So if you have a specific need for more phosphorus on your soil, rock phosphate is often the go-to. If you need a lot of or more potassium than is being supplied from these other sources, and that's pretty common for many of our high demand vegetables, let's say fruiting vegetables like tomatoes. A lot of what we go towards there are things like potassium sulfate. So this is mined potassium sulfate or sulfate of potash can be used for that purpose. Now, the phosphorus sources, rock phosphate, I will mention, there's good availability of those, but it's much slower availability compared to your synthetic sources, your synthetic fertilizers. All right. Well, let's think about crop nutrients requirements in perspective for a second here. So this is really important to understand. So plants need, let's say, 16 essential nutrients, right? But they do not need all of them in the same quantities. And so what I've put up here is the size of these different nutrients represent their proportion, or you can think of it as the requirement of the average vegetable crop. So you'll see we've got our macronutrients, nitrogen, phosphorus, and potassium. Uh, they're called macro because we need a lot of them. Then we have our secondary macronutrients, calcium, magnesium, sulfur, and then we get into our micronutrients, which are important but are needed in exceedingly small quantities. So the ones we most often run into in Michigan in terms of micronutrient deficiencies are going to be things like manganese, boron, and zinc, um, but still required in fairly low quantities. Now, I want to talk a little bit. One thing you'll notice is that phosphorus is pretty small here. So it's a macronutrient. It's important, but it is not needed in the same quantities by the plant and anywhere near as much as nitrogen and potassium. So this is your, annual reminder that, if your fertilizer program or the fertilizers you're applying has a lot of potassium or phosphorus in it, just as much as your nitrogen and potassium that you're adding. Oftentimes, this isn't a great thing, and you're adding more phosphorus than you need to. And this is particularly common with organic fertility sources because of those imbalanced nutrient ratios. All right. And just a real quick comment here. Why do we care about over applying phosphorus? Well, environmental issues, so harm to waterways, algal blooms. I won't go into too depth on that. I think we're pretty familiar. But there are some regulations as well that we use as guidance. So the Michigan Nutrient Management GAMP, so the generally accepted agricultural management practices, do have guidance on applications of phosphorus depending on your soil test phosphorus levels. So if you're in a situation where you've got above 75 parts per million phosphorus, then you should think about only applying phosphorus up to crop removal. If you're above 150 parts per million phosphorus, that's when technically we're not supposed to be applying additional phosphorus to those fields due to environmental concerns. Now, uh, in a lot of organic systems, we have very high phosphorus levels, and so that's something to keep in mind. Also, economics wise, if you're spending money on nutrients you don't need, why do it? One question that comes up though with these high phosphorus levels, if you have excessive phosphorus, does it cause problems for the crop? Usually not. If it's high enough, you can have some issues with competing nutrients and precipitation and things like that. But for the most part, you're not going to have crop issues from excessive phosphorus in your soil. All right. So let's switch gears a little bit. I know being a webinar, this will be a rhetorical question, but what's wrong with these sunflowers? And I'll answer it. We've got yellowing leaves on the lower part of the plant, so the older leaves. If you could see these up close, like in the picture on the right there, we'd also have some stunting and reduced growth. And these are hallmark symptoms of nitrogen deficiency. And in organic production systems, this is something you run into all the time, particularly early in the season. And so nitrogen is really the wild card. It's the one, we don't have it on our soil test results usually because it's so dynamic and it doesn't stick around. So it is the most often limiting nutrient in crop production. And part of that is because, well, it's requires biology to release from organic matter and amendments. It's very dynamic in that way. And once it becomes plant available, so it's converted into plant available forms, nitrate and ammonium, it's easily lost from the soil, whether it's through leaching down or through gaseous losses, denitrification, volatilization into the atmosphere. So it doesn't stick around really easily. Um, and of course, with this, it brings a lot of environmental consequences, just like phosphorus. So it's another one that we want to get as much of it in the crop and as we can. And there's also, it's also a challenge because there's not only crop issues, yield loss with insufficient nitrogen, but we also can run into quality, pest, and disease issues when we have excessive nitrogen in various vegetables. So nitrogen is the nutrient that we are most often worried about in pretty much all cropping systems, but especially in organic systems. So we're going to spend a little bit of time talking about what we need to know. So key concepts for nitrogen management from organic systems. So three questions we need to be able to answer for any kind of sources we're using. So first, how much of the nitrogen in that organic fertility source is going to become available in the first season? Second, when will it be released? So what's going to be the timing? And then finally, how much will it cost? And if we have a general idea of these three things, we can use it to inform our management. Okay, so first, meeting crop nitrogen demands. So, all of this starts with understanding across the great diversity of vegetables that many of us are likely growing, what are the nitrogen requirements for these crops. And of course, it's going to vary, right? So most of us have a general sense of what's going to be, a low nitrogen demand crop, things like radishes, short duration, peas. Those are going to be on the lower end of the spectrum. So recommendations might be about 50 pounds of nitrogen per acre. But then we have our very high demand vegetables where we may be pushing 150, 180, upwards of 200 pounds of nitrogen per acre under certain conditions. And so, where do you get these recommendations? Well, this is a table straight out of that nutrient recommendations for vegetable crop bulletin that I presented earlier. So, take a look there for your specific vegetable crop. Now, the next question is, well, especially in organic systems where maybe we've been building this organic matter over time, how much nitrogen can we expect from that native soil organic matter? So things that have been applied in the past and built up over time. So uh, this is a conservative estimate here, and estimates range from, between 10 pounds of nitrogen per acre per season all the way up to 40 pounds of nitrogen per acre per season per percentage of soil organic matter you have in your soil. And that's going to vary from depending on what your soil type are and your conditions. But it's notoriously hard to predict. Um, so we take a pretty conservative approach here and say, let's say you can expect about 10 pounds of nitrogen coming from each percent of organic matter in your soil. An important thing to keep in mind is that these recommendations generally assume a normal amount of soil organic matter for your soil type. So if you're going to claim a credit from soil organic matter, I usually suggest claiming a credit for organic matter that's above typical values for your soil type. So for a sandy soil, values claiming a credit for a percent organic matter more than 2, let's say. For heavier soils, maybe more than 4. Um, but one of the things you quickly see is that for our high demand vegetables, it's very difficult to meet crop demand in the season just from uh, percent organic matter, even for organic matters or for soils that you've been building over time. All right. So we're going to have to use some of these organic fertility sources to meet that demand. And one of the key things we have to understand is not just how much nitrogen is in organic fertility sources, but how much of that is actually going to become available in the first season. So this is a bit of a busy slide here. Um, but I want to highlight basically all this information is based on another old but useful, one of the original resources here called the Organic Fertilizer and Cover Crop Nitrogen Calculator from Oregon State University. And what it does is it helps you predict how much of nitrogen in an organic fertilizer or cover crop is likely to become available in the first season. And what's going on here is when you add an organic fertility source to the soil, we've got both carbon and nitrogen, right? And the microbes, when they decompose that carbon, uh, they're going to use it, they're going to decompose as much carbon as you give them. Now, if you also give them in that material enough nitrogen to build their bodies, they'll release the rest of that nitrogen in available forms that plants can take up. Now, if you apply a material that doesn't have a lot of nitrogen in it, well, they're going to use all that nitrogen to decompose the carbon, and then they might go scavenging for nitrogen from the soil, and you're going to actually reduce the nitrogen availability for a following crop. So a lot of this percent availability here is based on that balance between carbon and nitrogen in your materials. And it can generally, you can predict it pretty well just from what the percentage of nitrogen is in the materials you're using. All right, so uh, let's start with our highest nitrogen materials. So let's say something like feather meal or blood meal or a lot of these combined products. So these are organic materials. Let's say it's about 13% N. for feather meal. That's really high for an organic material. Now, in that case, about a maximum of 75% of that nitrogen in that product is going to become available in the first season. And that's more or less on average the maximum that you'd expect from organic materials. And you get that for pretty much any organic fertilizer. That's, above about 7% nitrogen. So those are your high-end materials. Then we have things like raw manures. So poultry manure. This might be 3.5 to 4% nitrogen. There you can expect about 35 to 50% of that to become available. And it's similar for high nitrogen cover crops like legume cover crops or brassica cover crops, for example. You can also expect, in that range between 30 to 50% of that nitrogen become available. Composts are a little different because they've already been decomposed and we have, a lot of stable organic matter that's contained in those. But for, let's say, a dairy compost, similar to, dairy do or something, we've got up to about 1% nitrogen. The percent availability is still pretty low. So it may be between, not getting much of any of that available in the first season up to around 20 to 30%. So much lower availability. And then finally, just we'll mention, if you have low end cover crops like stemmy rye or straw, things that have very low nitrogen compared to the amount of carbon, that's where you can expect to not get much of that nitrogen back in the first season or even have it tie up nitrogen. All right. So how do we apply this concept? Let's go through calculations. So calculate fertilizer rates considering this first season nitrogen availability. And I know everybody's excited for some math in the morning. But what do we do? So if we want to determine how much poultry litter we need to apply to meet the demands of a winter squash crop, first, we're going to refer to our bulletin. We're going to find that we need our recommendation on mineral soils is 80 pounds of nitrogen for hard squash. We're going to look at our product label uh, or our manure analysis for that poultry litter, and we're going to find that, okay, we're about 4% nitrogen. And then this is the key step using that the fertilizer and cover crop N calculator. We're going to estimate that about 50% of that is going to become available in the first season. And then we come out with our final estimate of about 4,000 pounds per acre. So 2 tons of this poultry litter should be able to meet that demand in the first season for that crop. All right. So does that work? So we've done a whole lot of these calculations and a lot of different studies over the years with different vegetable crops, looking at rate responses to organic materials. And so in this case, this is from last year. We were interested in meeting broccoli nitrogen demands with poultry litter. Now, key thing with broccoli is broccoli has much higher nitrogen demands than a winter squash crop. And it turns out in this particular year, we achieved maximum yield with 180 pounds of plant available nitrogen per acre from poultry litter. And that's a little higher than we normally recommend at MSU, but this was a sandy soil and we had a fair amount of loss conditions in this year, hence a high rate of nitrogen required to maximize yield. Now, the point I want to make though is, so if we had not considered percent availability, um, then we would have only applied about half the poultry litter as we did. And that would result in about a 25% yield decrease if we didn't consider that percent nitrogen availability. And so I think this is a mistake that's gotten made many times in the past. And organic yield gaps between conventional organic crops, a lot of it is often due to just, not getting enough nitrogen fertility for those organic crops. Now, maximum yield is not everything, obviously, and there's a lot of other considerations involved as well, right? Whether you're meeting your market and also keeping economics in mind. So this is the equivalent that 180 pounds of plant available nitrogen required 9 tons of poultry litter. Um, that's it can be expensive, and there's also some environmental challenges with that as well, right? Okay, and this is another example from a study that we did in butternut squash, where we were actually comparing supplying 75 pounds of available nitrogen either with conventional sources as urea or as poultry litter. And the key point here is we ran that calculation, but still you can see the poultry litter did not quite uh, we see more nitrogen deficiency where we use the poultry litter in this particular year. And what it came down to was it ended up being a really cool and dry period after we applied these fertilizers. And so we did not have anywhere near the same availability as we expected from the poultry litter in those conditions. So there's a lot of considerations into how much will actually become available in a given season because we're relying on all those things, some of which I've listed here, that influence decomposition. All right. Sometimes a visual is nice to drive home uh, s- some of the differences in how much product for we have to apply to supply the nitrogen demands, given these differences in availability and nitrogen percentages in the product. So let's say we wanted to apply 120 pounds of nitrogen per acre. Um, if we supplied it with urea, so this is a synthetic source, 46% nitrogen, nearly 100% of that is going to become plant available. It takes about 260 pounds. Now, if we use feather meal, high-end organic fertilizer, 75% of that available, it's going to take about 1,300 pounds. Manure, uh, it's going to take about 6,000 pounds of poultry manure. Now, if we tried to do this with compost, again, we've got 1% nitrogen and only about 20% of that might become available. It's going to take 60,000 pounds of compost. And so this is not an uncommon rate uh, on smaller scales. It's usually not economically viable for broad acreage organic production. But this is the equivalent of a little less than, let's say, an inch of compost. So many smaller scale producers are applying this, amount every year. And so one of the things I want to encourage people to think about is this is great. Compost has other benefits, right, for building soils. But it may not be necessary for your maintenance applications every year. It may be best to apply this level of compost at the beginning when you're building soils and back up off. So key message, don't chase nitrogen with compost because with that nitrogen, you're also going to be bringing just as much phosphorus and potentially other nutrients that you don't need. All right, the next thing we think about is timing of release. So a couple key points for timing from organic materials. So let's say you incorporate one of these high uh, nitrogen organic materials. So release from those materials is going to be slower release than a synthetic fertilizer. These are organic sources, but some of it can be actually quite rapid. So usually for high-end materials, we're looking at a considerable amount of that will become available within the first 2 to 4 weeks. Now, still crop nitrogen demand, because we have to apply these often before planting. That's going to pick up later. And an important point I want to make is that few organic materials uh, are ever going, if you apply them right at this period of peak demand, mineralization is not as fast as uptake by some of our very high demanding vegetable crops. So it's very tough to keep up. So organic materials are always slow enough that you need to think if you're going to be doing side dressing, you need to think closely about your timing of when that's applied to make sure it's actually available when the crop needs it. Now, we often run into these situations as a result is that we have a bunch of this nitrogen that's vulnerable to loss early in the season before the crop needs it. And so if you get a leaching rain, uh, it you may not have sufficient later on during high demand periods. A couple additional timing considerations that kind of make this more challenging as well is, when we're dealing with raw manure, we also, for food safety, have pre-harvest intervals. So either 90 or 120 days uh, that material needs to be applied before harvest, depending on whether the crop is going to be touching the ground or not. So that extends for some crops the period where we've got available nitrogen in the soil, but no crop taking it up. Another important thing to keep in mind is that many of you may be familiar with the concept of plant back periods for high residue cover crops. So if you incorporate a lot of fresh organic residues, you want to wait at least 10 to 14 days before you plant your crop. And this is to prevent issues with seedling injury. So there's a lot of dynamic things going on when you have rapid decomposition going on in the soil there. So this applies to cover crops, but it's also something you need to keep in mind for incorporation of fresh manures, as well as a lot of these high-end organic fertilizers. Okay. Cover crops can also, so we know, I wanted to say a few things about cover crops. Obviously, we know that they provide lots of potential benefits in production systems. With respect to nutrient management, though, or organic fertility, legumes are important because they have the potential to fix atmospheric nitrogen and provide a an additional source of nitrogen to systems. And we also, from both an environmental standpoint and a nutrient availability standpoint, uh, many cover crops can scavenge and re-release nitrogen to following crops, especially those like brassicas that have high quality or high-end residues. So this is just an example of how sometimes we can combine these practices uh, to get the most out of getting nutrients to from organic fertility sources to crops. So this was a study that a former PhD student of mine worked on, where we were interested in how we could combine fall poultry litter applications, again, which many people do out of, food safety requirements to make sure that we have enough separation. Combine that with oilseed radish fall cover crop. And the key point here was that, especially on these sandy soils, this is an overhead image of the resulting acorn squash the following season. If we just use poultry litter, we lost a lot of that fertility over the winter and early spring, a lot of that nitrogen fertility. But when we combined it with an oilseed radish cover crop, that cover crop retained and recycled a lot of those nutrients and made them available to the following squash crop. And we ended up with both higher yields and better nutrient use efficiency. All right. So quickly, I'd like to talk about just that concept in general of how do we uh, maintain as much of this nitrogen as possible when it's so easily lost. So one of the things is to, well, protect it. In vegetable production systems, covering the soil during certain periods of the year is a very effective method of doing this, especially when it's paired with good irrigation management. So things like plastic mulch, if you've got a hoop house, if you're working in a hoop house, you're controlling basically the water that is moving through those soils. Fallow tarping on a smaller scale is also something that's gaining a lot of um use as well. But again, good irrigation management is the key because if you're over irrigating below the root zone in any of these situations, um, the covering is not going to be that effective. All right, and then another thing you can consider that we often recommend, especially in conventional systems, is split applications. So only put down enough nutrients for what you need early in the season, and then you come back during that higher demand period and supply nutrients at that point more in sync with the crop demand. Now, side dress, fertigation, we won't talk too much about foliar, but these are all methods that are at your disposal as in an integrated nutrient management program. The key point I want to make here, though, is that timing is critical with organic sources. So we have a lot of organic, like fish emulsions, fertigation that happen. We'll also, see top dressing with granular products during the season. There's a danger with that if you don't consider how much time it takes for those products to become available. And we've seen this in our trials again and again, where it's really important to have that bank of available nitrogen from an organic source early in the season for the crop. Because if you lose that to a heavy rainfall event or something, it's hard to catch up with an organic source later in the season. So just you got to pay attention to timing of side dress applications if you're using an organic source. So I'll just mention briefly, this list of organic nitrogen fertilizers that you have at your disposal. There's obviously many more than this. So we've got plant products, animal byproducts, fish products, um, and also some mineral sources. So if you're organically certified, up to 20% of your nitrogen can come from mined what we call Chilean nitrate, which is basically sodium nitrate. And this is a mineral source, so 16% nitrogen. Um, if you apply that to the soil, 100% of that will become available. So key point though, the principles we've talked about so far apply across all these products and combined products. And the mineral sources, that sodium nitrate, especially if you're in an integrated system, either using sodium nitrate or if you're in an integrated system using uh, conventional fertilizers, nitrogen fertilizers, those are great for responding to adverse weather. So a leaching rain, a rescue application, those are going to be, you're going to want immediately available nitrogen in those cases. So often the organic products are best or are going to perform best pre-plant when you're able to give them some time to become available. All right. The last piece of information here we need to consider is cost, right? So in this slide is just to highlight two things. So one, costs vary widely across organic nitrogen sources. And the other thing is that it's hard to know what you're really spending or compare different organic fertility sources if you don't actually, again, look at not just dollars per pound of nitrogen in the product, but you want to look at dollars per pound of that plant available nitrogen in the first season. So taking into account that percent availability. And then you'll start to see where you get some wide differences. So just for comparison, and I want to point out, none of these numbers are current. Use your own numbers. It's going to vary widely across the state and other locations, but they're just to illustrate some of the general spread. So urea, that's about, 60 cents, let's say, per pound of available N. Turkey litter and poultry manures are one of our dominant sources for larger scale organic production in Michigan. You might come in, around $2 or so per pound of nitrogen, but it's still a very inexpensive source for organics. Then we move up and get more expensive, especially as we get to some of the liquid fish or liquid kelp products. Some are competitive, some are extremely expensive when you actually do the math. And the last thing I want to point out, this is not an endorsement for hairy vetch cover crop in particular, but legumes, you can also do this calculation based on their seed costs and how much of the nitrogen you expect them to fix. And sometimes it comes out pretty competitive if you can integrate these into your systems. And that's a much bigger discussion as well. But don't forget about legume based nitrogen, especially in organic systems. Now, I do want to pitch as you're considering whether you're an organic or an integrated system, take a look at this tool from Jonathan Laporte at MSU Extension called the Fertilizer Cost Comparison Tool. It's a little complicated. It's a spreadsheet-based thing, but it really does help you account for increasingly complex fertilizer programs. So looking at granular, liquid, foliar, specialty products. And if it's not specifically built for organic materials, but if you incorporate that plant available nitrogen percentage yourself, you can use them in this as well. Because the reality is we're all making multiple nutrient applications throughout the season. It's increasingly complex, and this can help sort out some of those calculations. So take a look at that. All right, and I'll leave everyone here with a quick comment on, well, how do you actually, with what we've learned with any kind of fertility program, especially if you're, uh, addressing integrated nutrient management, you want to incorporate some compost or manures in your system. But let's say you're not just a large scale, producing, 50, 100 acres of squash. You're on a diversified operation, and we've got, 30 different crops being produced. We've got flowers in there. Things are coming in and out of different beds over the season. I understand that these systems get increasingly complex, and it's hard to optimize nutrients for everything. But this is kind of a general workflow that we can consider. So first, make sure your fall or early spring soil testing, whatever works for your system, and you use that to get a handle on what your nutrient bank is and adjust pH at that time because that takes time. Second, consider a base organic matter application. So this is, optional depending on your system, but if you're interested in building organic matter over time and you see some utility from a compost, let's say, uh, choose your rate of that compost based on phosphorus recommendation or your removal limit. And then as you're doing that, that's hopefully also going to supply some microbes or micros as well as microbes. And make sure you're also watching your pH over time, especially with dairy-based compost. Next, okay, you've got your uh, nutrient recommendations. Let's think about pre-plant fertility. So you're going to want to credit nitrogen from any cover crops, compost, or manure, or particularly high organic matter you have. We see this often in hoop house systems where we've built up 8% organic matter on a relatively coarse soil. Yeah, you should take a credit for that. So we take a credit for that, and then any additional nitrogen, you can use a fertilizer or a higher end fertilizer to meet that desired baseline nitrogen level and any remaining phosphorus or more likely potassium recommendation. And the last part is your tuning knob. So keep a really high end fertilizer, or if you're integrated, keep your synthetic nitrogen sources on hand uh, for side dress or fertigation for your heavier feeders as needed throughout the your crop uh, your rotation of crops. And you can also use that for response to weather. So it's always easier said than done, but that's a bit of a framework of how we think about putting together a system for uh, a nutrient management system for complex vegetable production. All right. Well, with that, I'll wrap it up. And I just want to say thanks for everyone who attended today.